Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So in this video we will discuss about exercise 5 for per unit system. Okay, so look at to the exercise 5. Okay, the three-phase power and line-to-line ratings of the electric power system shown in figure 12 are given below. Okay, we have a one line diagram. We have a generator. We have a transformer 1. We have a transmission line, transformer 2, and load, okay, or motor. Okay, so this is the rating of the element G1, T1, T2, motor, and the line. Okay, this is the line to line voltage, because the information given to you is line to line ratings. Okay, this is a impedance, or sorry, this is the reactance of the G1 in per unit. Okay, this value based on this voltage and this apparent power, similarly to T1, T2, motor, and the motor. Okay, so the question is okay, you need to draw an impedance diagram. You need to draw an impedance diagram and showing all the impedances in per unit, which means you need to draw the impedance diagram and it shows all the impedance information in per unit. Okay, on a 100 MVA base by using this as base. Okay, and then you need to choose 20 kilovolt as the base voltage base for the generator. Okay, question A. Okay, so next look at to the question A. Okay, draw the impedance diagram showing all the impedances in per unit based on 100 MVA base, and then choose 20 kilovolt as a base voltage base for the generator. Okay, generator, now you have to determine V base for the generator equal to 20 kilovolt. Okay, which is the new base of the generator equal to 20 kilovolt, which is equal to the old base of the generator equal to 30 kilovolt. Okay, so this is your single line diagram. Then you need to first of all you need to determine the base value of the generator. Okay, so the base voltage of the generator, we call it VBG1. VBG1, which is on the low voltage side of the T1. Okay, this is a low voltage side of the T1. Why low voltage? Because we have a 20 kilovolt at the primary, 200 kilovolt at the secondary. Okay, so the base value equal to 20 kilovolt. Okay, hence the base value on its HV equal to, by using the turn ratio of the transformer, so V base at the high voltage side, we call it VB1 equal to 200. Okay, because V2 over V1 equal to N2 over N1. Okay, that one is the transformer ratio. Okay, 200 kilovolt. Okay, this fix the base on HV side of the T2. Okay, this is a V base of the T1 at the secondary side, which is equal to the V base of the primary side of the T2. Primary side of the T2. T2 basically primary side equal to high voltage. Okay. Okay. So the base value of this one equal to base value of secondary side of the T1. Okay. From the single line diagram, one line diagram, we can see that base voltage of the T1 at the secondary side equal to base voltage of the primary side of the T2. Okay, so equal to 200, and its low voltage, this is a low voltage, equal to 20 kilovolt. So you can determine according to the transformer ratio, okay, which is V2 over V1 equal to V2 over V1. Okay, so the base voltage of the secondary side of the transformer equal to 20 kilovolt, which is equal to the base voltage of the motor. Okay, base voltage of the motor. Okay, this is a new V base. We call it V base new of the motor. Okay, look at to the original data. The X per unit of the motor basically is based on the old value of the, based on the 18 kilovolt. Okay, so you need to determine the new XPU. Okay, so we know that this is a general equation of the per unit value, whether you need to determine reactance or Z. Let's say if you want to determine X, X per unit new equal to X per unit old times S base new over S base old times V base old over V base new square. Okay, if you want to determine reactance. In this case, we need to determine reactance because all the information for the generator, transformer, and motor in X. Okay, if you want to determine Z, you can replace this X with the Z. Okay, Z per unit new equal to Z per unit old. Okay, by using the same equation. Okay, so the generator and transformer reactances in per unit based on 100 MVA. Okay, based on 100 MVA, but they have a transformer and generator, they have the same V base old and V base new. V base old and V base new. So which means that the ratio of V base old over V base new equal to 1. 1 square equal to 1. Okay, so you can determine for the G, okay, for the G, for the T1, for the T2, and then for the motor. Okay, for the motor, we have VB old, VB old equal to 18 kilovolt, and V base new equal to 20 kilovolt. Okay, so you need to calculate. Okay, then you need to determine the base impedance of the transmission line. Okay, what is your transmission line? This is a transmission line. You need to determine the Z base of the transmission line. Okay, transmission line, you have information of S and Z. Okay, you have information of the voltage equal to 200 kilovolt. This is the base value of the transmission line. Okay, S value, S base equal to 100. So V base transmission line equal to Z base transmission line equal to V base square divided by S base. Okay, so that the per unit value of the line impedance Z per unit equal to Z actual of the transmission line. This is a Z actual of the transmission line divided by Z per unit of the transmission line. Okay, then you can draw the per unit value. Okay, based on the single line diagram. Okay, you can draw the per unit impedance, per unit impedance diagram. Okay, you have a EG, and then you have a XG connected to the transformer T1, and then connected to the transmission line. Okay, this is the X per unit of the transmission line, and then this is the X per unit of the transformer 2 connected to the X motor. Okay, reactance of the motor per unit value, and then connected to the EMF of the motor. Okay, this is the impedance diagram of the of this one line diagram. Okay, one line diagram or single line diagram. Okay, we have done for the question A. Next, question B. Okay, question B, the motor. Okay, you have a motor. This one you have a motor. Okay, now your motor is drawing 45 MVA, 0.8 power factor lagging at a line-to-line terminal voltage of 18 kilovolt. Okay, so determine the voltage and internal EMF of the generator in per unit, okay, and in kilovolt or in actual value. Okay, so first of all, you need to determine the complex power in per unit. Okay, complex power in per unit, since your S base, S actual equal to this one. Okay, 45 angle 36.87. Okay, inverse cos, inverse cos 0.9 as 0.8. Okay, so you can get the Z per unit. Okay, this is your base. Okay, so motor terminal in per unit. This is a motor terminal in per unit. Now you have a voltage. Okay, V actual equal to 18 kilovolt. Okay, over V base equal to 20 kilovolt. This is V motor per unit. So you have a S and V, so then you can determine the current, okay, current of the motor, because your S equal to, sorry, because your originally we have a S, equal to V I conjugate, so I equal to S conjugate divided by V conjugate. So I equal to S conjugate per unit divided by V conjugate so you can get a current in per unit. Okay, so from the impedance diagram, okay, you have a current, in series circuit, and then you can determine the terminal voltage of the generator. Okay, this is a terminal voltage of the generator equal to Vg. This is a positive and this is a negative, Vg, by solving KVL. Okay, by solving KVL, Vg equal to, okay, Vm plus, okay, plus I times Z, I times by ZL plus ZT1 plus ZTU. Okay, by solving this KVL, you can determine Vg in per unit. So you got a Vg in per unit. Once you got the Vg in per unit, then you can determine the actual value of Vg, because we know that Vg actual equal to Vg per unit times V base. In this case, V base of the generator equal to 20 kilovolt. So times by its per unit value. So you can get the magnitude of the Vg. Okay, in the actual value. So next question, determine the internal EMF of the generator. Where is the internal EMF of the generator? This is the internal EMF of the generator, EG. So now Vg, you have a Vg, then you can determine Eg based on the Kirchhoff voltage law. Okay, so Eg equal to Vg plus I times, okay, I times by Zg. Okay, so in this case, internal EMF of the generator, Eg equal to, okay, we have a two approach. Okay, you can determine based on Vg, or you can solve this Eg for the loop, for this loop. Okay, we have a two approach. In this case, the internal EMF of the generator in per unit, Eg equal to, okay, determine this Eg equal to, by solving this loop. Okay, to determine Eg equal to 0.9, okay, plus 0.9, which is our Vm. Okay, our Vm plus I times total Z. Okay, I by I, this is a current, times by Z. This Z basically is J 0.5 plus J 0.2 plus 0.3 plus J 0.5 plus J 0.2. Okay, this is a Vm. Vm equal to 0.9, this one. Okay, and then solving, and then you can solve for Eg, EMF for the generator equal to this value per unit, then you can convert to the kilovolt value. Okay, because Vg, Eg, because actual value equal to per unit value times by base value. This is a per unit value times by base value. Okay, or you can solve your Eg by using this point, because this one equal to Vg. Okay, so you just solve this KVL, also you can determine Eg, or you can solve these loops, this complete loops. Okay, Eg equal to Vm plus I times by this Z, this total Z. Okay, this one, this one, this one, and this one. Okay, so you can determine EG. From EG in per unit, you can convert to the actual value.